All right, and welcome to another installment of One and Done. I got a question here from a student that talked about the triangle inequality theorem. Now, I started going into this and I explained a little story that I had from when I was in elementary school. And my elementary teachers, and they were wonderful. What they did was they put a bunch of popsicle sticks out in front of us on our tables, and they all had different measurements in there. I think we were doing them about an inch to an inch and a half, 2 inches, and things like that. And what we had to do was we had to decide whether or not we could take those popsicle sticks and we could actually make a triangle. And what we were doing was essentially, didn't realize it at the time, but we were actually developing up this theorem that we're going to talk about, and it's called the triangle inequality theorem. See, triangles are made, they're made a specific way. When you're putting together, we know triangles have three sides. When you're putting the sides together of a triangle, the triangle inequality rule states this. If you take the two smaller sides of a triangle, the two smaller sides always have to add up to be a value that is larger than the third side. So if I take a look at the question that we have right here, if I'm looking at the situation, it says, which of the following sets of measurements could not represent the length of three sides of a triangle? Okay, that means three of these choices could be triangles, but one of them is not. So now to determine the one that's not, we go through each of these answers individually and follow the triangle inequality theorem. So we take the two smaller values of the three, we add them together, and if the number that we add together is bigger than the third side, the larger of the sides, then that is an example of what could be a triangle. But this question, some of them get tricky. We want to know the one that's not. So this is not a good answer right there because that guy could be a triangle. So then I go through and I do each one of these. So the two smaller sides are 3 and 7. Obviously, 3 and 7 are going to make 10. 10's bigger than 9, so that's not going to be answer. Then I get down to C, and I got 5 and 3. 5 and 3 come out to be 8. 8's bigger than 6. That's not the answer. But then all of a sudden, I put on the puppy brakes because I get down to D. And if I look at D, my two smaller numbers, 4 and 4, make 8. And unfortunately, 8 is not bigger than 9. So now, by default, that's the guy that cannot be a triangle. Somebody also brought the question, well, what if all the sides are the same? You don't have two smaller sides. Well, if you have a triangle where all three sides are the same, think. There's a name for that. Of course you can have a triangle where all the sides are the same. It's called an equilateral triangle. And that should be one of the most fundamental things that you learned about the triangle back in the day. The three types, the scalene, the isosceles, and the equilateral. So, of course, a triangle, if it has three sides and they're all the same, then if you pick any of the two sides that are the same, they're going to add up to be bigger than that third side. So that's totally fine. Anytime you see a triangle with three sides the same, you know that could be a triangle. Okay? So that was that. This is the triangle inequality theorem. I hope you found this both helpful and informative.